Hello everyone. This video will show how to evaluate composite trigonometric functions. Now let's go over this first example. So this is read as the cosine of the inverse sine of 3/5. The first step that we need to do so that we can evaluate this given expression that we have right here is to let this whole expression inside the parentheses equal to theta. Now, to cancel out this inverse sine that we have here, we're going to multiply both sides by sine. So once we multiply this right side with sine, this two will go away. So we're left with sine theta equals 3/5. Now let's determine what these numbers are relative to the angle theta. To do that, we're going to use the acronym SOHCAHTOA CAUSHACHO to determine what these are. So I'm going to go ahead and write that up here. So this acronym means sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, tangent theta is equal to opposite over adjacent, cotangent theta is adjacent over opposite, secant theta is hypotenuse over adjacent, cosecant theta is hypotenuse over opposite. So looking at this given fraction that we have right here, it says sine theta, so we're going to use this. So our 3 here is the opposite, while our 5 is the hypotenuse. So we go ahead and draw the right triangle. So if this is our theta here, opposite is the one across from it, which is 3. So I'm going to label this as 3. And our hypotenuse is 5, which is across the small square. So this is our 5 right here. So we can go ahead and say that this side right here is our A. This will be our B. And this will be our C. Our task is to figure out what this A equal to. So we're going to use the Pythagorean theorem, A squared plus B squared equals C squared, so we can solve for A. So I'm going to go ahead and write that up here. So we go ahead and plug in values. Our A is missing, our B is 3, and then square it, equals our C is 5, and then square it. So this comes out A squared plus 9 equals 25. We want A by itself, so I'm going to go ahead and subtract 9 from both sides. Since we want A by itself here, we're going to square root both sides so we can cross out the squared and square root. Our A then is square root of 16, which is 4. So this A right here is 4. Now let's label this given triangle that we have right here. This is again our opposite, this is our hypotenuse, and this is our adjacent. I'm going to go ahead and rewrite this given expression up here. We remember that we have defined this expression inside the parentheses as our theta, so that we can go ahead and say that we're looking for cosine of theta. Now we remember that cosine is adjacent over hypotenuse. So we can go ahead and determine the value that we have here. So that would be our adjacent is 4 and our hypotenuse is 5. So this whole expression that we have here is equal to 4 over 5. Now let's have another example. So using this expression that we have right here, we remember that we're going to let this whole expression inside the parentheses equal to theta. So that we can cancel this inverse cosine that we have right here, we're going to multiply both sides by cosine. So if we get cosine and arc cosine, we are going to cross this out. So we are left with cosine theta is equal to square root of 11 over 6. Now we're going to label this square root of 11 over 6 with respect to the angle theta. In here, we're going to use the acronym SOHCAHTOA CAUSHACHO. So this acronym stands for sine, cosine, tangent, cotangent, secant, and cosecant. Since we're looking for cosine here, we are going to use this acronym. So this is adjacent over hypotenuse. So square root of 11 is the adjacent, 6 is the hypotenuse. So let's go ahead and draw the right triangle. So if our theta is located here, square root of 11 is adjacent. So I'm going to go ahead and write that down here. That's square root of 11. 6 is the hypotenuse. It has to be on the longest side. So this is 6 right here. So we actually have a right triangle with two legs A. This is our B and this is our C. Looking at this, we are missing B, so we can go ahead and use the Pythagorean theorem to solve for B. So what I do is I will substitute this 6 into the C and this A into the square root of 11 into the A, and I will solve for B. So our B here is equal to 5. So I'm going to go ahead and label this right triangle right here. This is our opposite, adjacent, and hypotenuse. I'm going to go ahead and rewrite this given expression that we have down here. We assign it with theta, so this comes out tangent theta. Now we remember that using this acronym right here, tangent theta is opposite over adjacent. So looking at the right triangle right here, our opposite is 5. Our adjacent is square root of 11. Since we have a radical at the denominator, we're going to multiply this by square root of 11 over square root of 11, which is pretty much 1. So we can go ahead and say that our tangent of theta is equal to 5. Square root of 11 over square root of 11 times square root of 11 is 11. So this whole expression that we have right here is equal to 5 square root of 11 over 11. So that is how we evaluate a given composite trigonometric function.